In this video, we're going to go over section 3.3 from your textbook, which is called Basic Probability Rules. So the first and one of the most important rules of probabilities, this is one of the things that can help you determine if your answer is a reasonable answer or not, is figuring out how big or small a probability can be. Every event must occur between 0% and 100% of the time, which means that for every event E, the probability of E must be between 0% and 100%, which in decimal form is between 0 and 1. Right, so this notation in here, P with the little E in parentheses, that's read as probability of E. So this means that if you ever get a negative answer or an answer greater than 1 when you calculate a probability, you know that you made a mistake and you can go back and find your error, because probabilities must be between 0 and 1. So you should never get a negative answer and you should never get an answer that is bigger than 1. We learned this in the last section, but an event with a probability of 0 must be the null set. Remember, the symbol for the null set looks like this. It's a O with a diagonal line through it. And as we discussed earlier, this type of event is called an impossible event. This is one question that I always like to ask on the quiz. I think it's a pretty easy question. So usually I'll ask, what is it called when you have an event with a probability of 0? And then you'll tell me it's an impossible event. Here are the 3 rules of probabilities that we've just discussed. Rule 1 says the probability of the null set is 0. The second rule we haven't actually touched on yet. This is called a certain event. It says the probability of the sample space is 1. An example of this is if you're rolling a single dice, what's the probability that you roll between a 1 and a 6? That probability would be 1. So that's called a certain event. And then the last rule and most important rule of probabilities is that probabilities must be between 0 and 1. Let's look at our first example. It says a single die is rolled once. Find the probability of A, the event E, which is a 15 is rolled. And then B, what's the probability of event F? A number between 1 and 6 is rolled. And then C, what's the probability of an event G? A 3 is rolled. Here I have a picture of a dice just in case it's been a while since you've seen one. This is 2 dice, but don't forget we're just rolling 1 dice here, which is called a die. So let's look at the probability that an event E, which is a 15, is rolled. So what's the probability that you roll a 15? Rolling a single die can only produce the outcomes 1, 2, 3, 4, 5, or 6. So the probability of rolling a 15 is 0. So since you can only roll the numbers between 1 and 6, the probability of rolling a 15, that's impossible. So the probability is 0. And just to remind you, this is called an impossible event. So anytime you get a probability of 0, that event is called an impossible event. Next we have find the probability of event F, which is a number between 1 and 6 inclusive, is rolled. Inclusive just means we're including 1 and 6. Once again, recall, rolling a single die can only produce the outcomes 1, 2, 3, 4, 5, or 6. So the probability of rolling a number between 1 and 6 is 1. And remember, I just told you this is called a certain event. This is the same thing as rule 2, which was what's the probability of the sample space. So 1 through 6 is the sample space. So the probability of rolling a number between 1 and 6 is 1, which is the same thing as 100%. In math, we always, in this class and in your statistics class, anytime you're reporting a probability, you will always report the probability in decimal form, like I've done here. So this 1 is in decimal or fraction form. You would never report a probability in one of these classes as 100%. Our last event is event G, so find the probability that a 3 is rolled. As we said before, rolling a single die can only produce the outcomes 1, 2, 3, 4, 5, or 6. 3 is one of those possibilities, so it's 1 out of 6 possibilities. So as you recall, probability is success over total. So there's one way you can roll a 6, and there's one way that you can roll a 3, and there are a total of 6 possibilities. So success over total would be 1 over 6. Now let's move on to what I consider to be the most difficult questions of this section, which is where we're rolling a pair of dice. In order for you to do these problems, it's going to help you to have this little table printed out and have it filled out. You are welcome to use this filled out table on your quiz. So on quiz 3, you can either redraw this table or you can print it off. I have a PDF uploaded on D2L, and it's called pair of dice table, or pair of dice probability table. You can print that out, you can fill it out, and you can use that paper on the test or on the quiz. So make sure you print this out or either copy it down onto your own paper before you do the next problem. If you need to pause the video to copy this table down, we're about to start filling it out. So if you need to pause it, now's the time to do so. Example 2. A pair of dice is rolled. Find the probability of each of the following events. So if you see a problem like this, you know that you're going to have to use your little table. Now I'm going to show you how to fill out that table in just a second, but let's look at what some of the questions will look like. All of the questions on your homework will look like part A. So they'll say find the probability that the sum is 7. So let's think about the ways that you could roll 2 dice that sum to 7. Right? You could roll a 1 and a 6. You could roll a 2 and a 5. You could roll a 3 and a 4. Or then you have to flip it around. You could roll a 4 and a 3, a 5 and a 2, and a 6 and a 1. Right? But that's a lot to keep up with for every problem, which is why we're going to fill out that table. So that all the problems on your homework that deal with a pair of dice will look like part A. Now I'm going to throw in some tougher problems here that we're going to do together, but you won't have to do these on the homework, and most likely the question that's on the quiz will look most like part A. But we're also going to look at the probability that the sum is greater than 9, and we're going to look at the probability that the sum is an even number. Alright, let's start filling out our table. Here's your table. Now we are going to fill out all of the possible outcomes that could result when you roll 2 dice. Now, I'm going to start with the outcomes 1 and 1. So this would be if on both your dice you rolled a 1. You could also roll a 1 and a 2, a 1 and a 3, 1 and 4, 1 and 5, and 1 and 6. So the first column here, this is like my first die, and then this second column, that's my second die. Okay, now let's proceed to fill out the rest of the table. I'm going to do this a little bit quicker, so if you need to pause the video to get your table filled out, make sure you get this filled out correctly. That way you can answer all of the questions correctly. All right, so you could roll a 2 and a 1, and then very similar, it's going to follow the same pattern. You could roll a 2 and a 2, 2 and 3, 2 and 4, 2 and 5, and 2 and 6. Now I'm stopping at 2 and 6 and at 1 and 6 because a dice only has 6 sides, so you can't roll a 7. You can't roll a 0. Alright, so I'm going to continue filling out my table. My next column is going to be my 3s. So 3 and 1, 3 and 2, all the way to 3 and 6. Then my next column is my 4s, my 5s, and my 6s. So take a minute and finish filling out your table. The next thing we need to do is fill out or fill in these little blank spaces that we have around the table. This is where we're going to put the sum of the dice rolls. The way that we filled out this pattern, I filled it out this way for a reason, because this makes all of the die rolls or the dice rolls follow a pattern. Notice that the 2 outcomes here sum to 2. So those sum to 2. So I've written 2 on the outside under the sum column. In the next row, if you kind of draw this little diagonal line, these 2 dice rolls, what do they sum to? Both of those sum to 3. Draw your next diagonal line. Those 3 outcomes all sum to 4. We're going to continue this pattern. These 4 outcomes sum to 5. These 5 outcomes sum to 6. The longest diagonal in the table, all of those 1 and 6, 2 and 5, 3 and 4, and so on, all of those sum to 7. So I'm just adding up the 2 dice rolls as we go through here. The next diagonal line, those all sum to 8. Our next diagonal line, they all sum to 9. Our next diagonal line, they all sum to 10. You can see we're getting less and less as we're getting close to the end of the table. Our next line, 5 and 6, 6 and 5, those sum to 11. And then at the very end of our table, 6 and 6, those sum to 12. This is your table. This is what you want to have filled out on that little sheet for the test. So it's totally fine with me if you just copy this down onto your own paper, like if it's not convenient for you to print this out. I'm fine with you copying this onto your own sheet of paper. Just before you take the quiz, just show me, just show the webcam, show the camera where you've written it down on your own paper, please. All right, so let's use this little table to answer our questions. Here we're looking for the probability that the sum is 7. Recall that probability is success over total. So let's figure out what success and total mean in our problem. Success is going to be the number of boxes in this table that sum to 7. So let's look at the number of boxes that sum to 7. The total is going to be the total number of boxes in the table. This is pretty easy to figure out. It's a 6 by 6 table, so there's 36 boxes in total. So 36 is always going to be your total for these pair of dice problems. All right, but let's count up the number of successes. Let's count up the number of boxes that sum to 7. Now here's 7 right here. This is our sum of 7. So let's count up the number of boxes that are in that diagonal line. 1, 2, 3, 4, 5, 6. All right, so 6 boxes summed to 7. So 6 of the outcomes sum to 7. So our success is 6. Now our total, I just told you, the total for these problems, for the pair of dice problems, is always going to be 36 because that's the total number of boxes in this little table. It's a 6 by 6 table, so there are 36 boxes in total. So the probability of rolling the probability of rolling a pair of dice and the sum is 7 is 6 over 36. you do not need to simplify this on the homework or on the quiz. You can leave it just like this. If you want to simplify this, it's 1 over 6. If you want to simplify it, that's fine, but you don't have to. Now let's look at the probability that the sum of the 2 dice rolls is greater than 9. Just like before, I'm reminding you that probability is success over total. Here, success is the number of boxes that sum to 9 or more, so greater than 9. Total, once again, will be the total number of boxes in the table, which we already know is 36. So let's count up the number of boxes that sum to 9 or more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so there are 10 boxes that sum to 9 or more. So if probability is success over total, we know that there are 10 successes and there are 36 boxes in total. So our probability of rolling a sum that is greater than 9 is 10 out of 36. Once again, if you wanted to simplify this, I think this would be 5 over 18. You're welcome to reduce it if you want to, but you do not have to for either the homework or the quiz. Neither one. You don't have to reduce this fraction. Our last pair of dice problem in this section is find the probability that the sum is even. Probability is success over total. Here, success is going to be the number of boxes that sum to an even number. Once again, total is going to be the total number of boxes in the table, which we already know is 36. So let's look at the even sums. So the sums start at 2, which is an even number, so there's one of your success boxes. Those sum to an even number. Then our next one is 4. So 1, 2, 3, 4. 5, 6, 7, 8, 9. 10, 11, 12, 13, 14. 15, 16, 17, 18. All right, so 18, exactly half of the boxes sum to an even number. All right, so probability is success over total. There were 18 boxes that summed to an even number, and there were 36 boxes in total. So our probability is 18 over 36, which reduces to 1/2 if you want to do that. There's a couple more problems from the homework that I want to go over, so I'm going to do that pretty quickly here. I think you'll find that they're pretty easy. Here I want to go over section 3.3 homework problem number 1. Here it's a word problem, which I know some people don't like. It says, to determine the effect their salespeople have on purchases, a department store polled 700 shoppers regarding whether or not they made a purchase and whether or not they were pleased with the service they received. Okay, so a department store surveyed or polled 700 shoppers and they asked them 2 questions. They asked them whether or not they made a purchase and they asked them whether or not they were pleased with the service they received. It says, of those who made a purchase, so these are the people who made a purchase, 141 were happy with the service and 153 were not happy. Of those who made no purchase, 211 were happy with the service and 195 were not. Use probability rules when appropriate to find the probability of the event stated. Enter your answers as fractions. Alright, so first thing we're looking at is the probability that a shopper was happy with the service received. Alright, so we know probability is success over total. Well, the first thing that jumped out to me when I read this problem was the 700, which is our total. Alright, so success over total, 700 is going to be our total. Now, in this situation, success is that a shopper was happy with the service they received. It said that of the people who made a purchase, 141 were happy, and of those who made no purchase, 211 were happy. So let's add up those shoppers. 141 plus 211 is 352. All right, so there's your success, 352. We're happy with the service, and we know our total is 700. So the probability that a shopper was happy with the service received is 352 over 700. So 352, that's the people that were happy. 700 is the total number of shoppers that they polled. And again, that was in the first sentence. Now, for part B, I'm sure you could figure this out all by yourself. This is, once you've seen part A, part B is pretty easy. But let's look at part B together. It says, find the probability that the shopper or a shopper was unhappy with the service received. All right, so people that were unhappy. All right, so it says, of the people who made a purchase, 153 were not happy. And of those who made no purchase, 195 were not happy. All right, so let's add those up. 153 plus 195 is 348. All right, so success over total, our total is still the same. The probability that a shopper was unhappy with the service they received is 348 over 700. Now, once again, you don't need to worry about reducing these. You can enter these fractions in just like they are, but you want to make sure that you enter them in as fractions, not as decimals. And I know that because they stated right here in the problem, enter your answers as fractions. Okay, so make sure you pay close attention to the directions. Most of the time, they're pretty good about telling you what format they want your answer in. All right, last problem, y'all. This is section 3.3 homework problem number 2. Once again, I forgot to mention this on the last problem, but as I've said a million times, you already know this. All the numbers in red will be different on your homework assignment. So don't go copy these exact answers. I'm just showing you how to do your homework problem. All right, this problem says, a supermarket polled 1,000 customers regarding the size of their bill. All right, so what I just saw sounds like 1,000 is probably going to be our total. All right, so they polled 1,000 customers regarding the size of their bill. The results are given in the table below. Okay, so we have size of the bill. Looks like it goes from below $20 all the way up to $100 and above. And then they have the number of customers. So, for example, if I'm reading this table, I'm going to start right here. So there were 206 customers whose bill was less than $20. All right, so that's how you would read this table. If you go to the next row, there were 113 customers whose bill was between $20 and $39.99. Okay. All right, now it says use probability rules when appropriate to find the relative frequency with which a customer's bill is as stated. Enter your answers as fractions. All right, recall from the last section that we said that relative frequency, we had a long fancy definition for it, but what it all boils down to is that relative frequency is frequency divided by total. All right, so there's your little fraction. That's going to be how we format our answer. Now, what is frequency? Frequency just means the number or the count. So there's your frequency. That's your number of customers. And then our total, frequency over total is 1,000. So there were 1,000 people that they polled. Another way that you could get the total would be to add up all of the people, all the customers in that column. So, but it's easier since they just tell us that it's 1,000. If you want to add those all up and confirm that it's 1,000, you can. All right, we're looking for the probability, or sorry, let me say that again. The relative frequency with which a customer's bill is less than $40. All right, less than $40. All right, so let's look at our table. Those are the folks who had a bill less than $40. All right, if you go to the next row, that's $40 to $59.99. So everybody in the first two columns, those were the folks who had a bill less than $40. All right, so you're going to add up those two numbers. and divide that by the total. That's going to be your relative frequency. All right, so frequency over total is equal to 206 plus 113. That's your numerator. That's the frequency. The total we found out from the first sentence is 1,000. So just add up 206 plus 113. That's 319 over 1,000. Once again, no need to try to reduce. Just enter your answer just like this. So there's your answer. Now once again, I'm sure you guys can figure out part B since you've seen part A, but I'm just going to really quickly go through it and show you how to find the answer. So this is find the relative frequency with which a customer's bill is $40 or more. Alright, so let's look at our table. $40 or more, that is the bottom, let's see, 1, 2, 3, 4. So the bottom 4 rows. Alright, so sorry I went ahead and fast forwarded through all that, but there's our bottom 4 rows. Those are the people who had a bill greater than $40 or more. So I'm adding up 183 plus 179 plus 196 plus 123. All of those numbers add to 681 divided by my total, which is 1,000. So 1,000 customers in total. Alright, so hopefully you didn't find this section to be too hard. Like I said, I think the pair of dice problem is the most complicated, and I can tell you for sure you will definitely have one of those questions on the quiz. So make sure you practice with that pair of dice probability table. If you have any questions, as always, please either email me at jberry@ccga.edu, or you can always ask me a question on WebAssign.